Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts project at thunderbolts.info. A new scientific paper is challenging planetary scientists' ideas about the so-called volcanoes on Jupiter's moon, Io. Since the late 1970s, scientists on Earth have studied the tremendous plumes of material ejected hundreds of kilometers from the moon's surface. The theory that these plumes are volcanic in nature envisions Jupiter's gravitational pull creating tidal heating inside of Io. However, according to a recent geologic survey, the location of the so-called volcanic plumes is incompatible with the predictions of the tidal heating models. Lead author Christopher Hamilton says that the findings can't be reconciled with any existing solid-body tidal heating models. But the mysteries surrounding Io's so-called volcanoes trace back to their discovery in 1979.
On March the 8th, 1979, 3 days after passing Jupiter, Voyager 1 took images of Jupiter's moons to help the mission controllers determine the spacecraft's exact location. While processing the images of Io to enhance the visibility of the background stars, the navigation engineer Linda Morabito found a 300 kilometre or 190 mile tall cloud along the moon's limb. At first she suspected the cloud to be a moon behind Io, but there was no suitably sized body in that location. The feature was determined instead to be a plume generated by active volcanism. Now, this is the standard report you'll read about the discovery of the so-called volcanoes on Io. Of course, seeing a jet of material coming out of the surface of a planetary or a moon object, we immediately leap to the conclusion, because all we see on Earth are volcanoes ejecting material into the atmosphere, we just assume that the thing seen on Io was a volcano. And the only way for a volcano to be active on Io was some source of heat. In fact, a few months before Voyager 1 went past Jupiter, it had been predicted that there might be volcanic activity. The difficulty with all of this is that the plumes on Io, 190 miles tall, had a beautiful even umbrella shape, and also the plume was filamentary. It was discovered later in closer images from the orbiting spacecraft Galileo that the plumes had this beautiful symmetrical shape which dropped the material that was being shot towards space back to the surface in a beautifully shaped ring. Now, no volcano on Earth will do such a thing, nor will they produce that beautiful umbrella shape in the ejector.
As early as 1979, the noted astrophysicist Dr. Thomas Gold proposed that the energetic plumes on Io were not the product of volcanoes, but rather of electric arcs striking the moon's surface.
Tommy Gold, in November 1979, published a paper in Science, and he recognized this shape and the outbursts on Io as having an electrical origin. And he said that you would find that these are being generated by arcs striking the surface of Io. And the astrophysicists had already figured that there was current flowing between Jupiter and Io, and they'd calculated the amount so that there was a source for the electric current to produce these arcs. Tommy Gold made a few predictions based on this picture of Io's volcanoes as being electric arcs. He said the outbursts should repeat in a systematic way. The hot spots should be very hot in the small area struck by the arc, and also that they may be visible at night because they'd be giving off light, and that you would find there'd be spots of high temperature rather than large areas of slightly raised temperature, which is what you find on Earth with a volcano. There were several other things that he predicted, but about 8 years later, the plasma physicists Tony Peratt and Alex Dessler did a detailed study of the phenomenon of what's called the plasma gun effect, which is a kind of discharge in a low-pressure gas, as you would find on the surface of Io. And they said in that paper that the umbrella shape is typical of such a discharge, a plasma gun discharge, and that it would form a ring of debris around the plasma gun, as observed on Io. So here we have all of the requirements met by observation of an electrical model of these plumes on Io. On April 5th, it was reported that the volcanoes on Io are in the wrong place. Now, the wrong place is according to the internal tidal heating model. The argument goes that as Io gets closer to Jupiter, the giant planet's powerful gravity deforms the moon towards it, and then as Io moves further away, the gravitational pull decreases and the moon relaxes. And this flexing from gravity causes tidal heating. In the same way that you can heat up a spot on a wire coat hanger by repeatedly bending it, the flexing creates friction in Io's interior, which generates the tremendous heat that powers the moon's extreme volcanism. So says the report. The question remains regarding exactly how this tidal heating affects the moon's interior and produces the volcanoes. And this is where the problem has been found, because the volcanoes are offset from where the model predicts. No one has considered Tommy Gould's paper of 1979, nor the follow-up one by Alex Dessler and Tony Peratt, which shows that all of the features observed above the surface of Io are consistent with an electrical discharge. And here we have all of the models of what's going on hidden inside the moon not working. So what would you do? We observe volcanoes on Venus, on Earth, on Saturn's moon Enceladus, and on Neptune's moon Triton. And in each case, the models have had to be fiddled with to try and get any semblance of a description which matches the observations. The question is, how long is it going to take scientists to acknowledge the possibility of plasma discharge effects on planetary surfaces?
One of the greatest challenges to the theory of volcanism on Io arose in 1996. That was when the Galileo probe revealed that the plume of the so-called volcano Prometheus had moved tens of kilometers across the moon's surface since the Voyager mission of 1979.
Science magazine, on the 19th of May 2000, the report says Prometheus is a plume visible in every observation sequence by the Voyager and Galileo spacecraft. It has also been a persistent high-temperature hotspot during Galileo's tour of Jupiter. Although the plume has been stable in size, shape and optical properties, its source moved about 75 to 95 kilometres to the west between the times of the Voyager flybys in 1979 and Galileo's first images in 1996. The question immediately arises, how do you explain a volcano which moves almost 100 kilometres in just a few decades? The answer is that's not what we see volcanoes doing. What we do see when we have an arc on a surface is that it will move about, that it dances about, and this is the kind of thing that the electrical explanation can easily accommodate.
In recent years, Io has provided some of the best opportunities to differentiate the predictions of the electric universe from those of conventional science.
In 1999, I wrote a series of articles about Io and what would be expected. One of the things that I pointed out was that the hotspots would be as hot as the sun's surface, but they'd be very tiny and wouldn't be resolved by the cameras. So what happened, the Galileo orbiter made one of its closest passes by Io and imaged one of these so-called volcanoes. And the result was that part of the image was burnt out. It was white. It was in the location of the so-called volcanic discharges themselves. So what the artists at NASA did was to colour in the white areas red as if it was a volcanic lava flow. I called the article NASA's Christmas Colouring Book. I also in those articles pointed out that the spots themselves would tend to arrange themselves in a particular way, that they would be along the edges of a caldera, a so-called caldera. Because when you look at in the laboratory at electrical discharge machining, the effect is to erode sharp edges like those along the crater walls, or in this case, the so-called caldera walls. And that's precisely what was seen in those close-up images. So we have more confirmation in terms of the actual scarring observed. We have here a living laboratory of electrical machining of a planetary surface. Not only do we see here a kind of confirmatory bias, an inability to see beyond what you've been taught, but also it shows that the education of our scientists isn't sufficiently broad, because neither the astrophysicists nor the planetary geologists have ever been taught the effects of electrical discharges on surfaces and in plasma and in deep space. With this simple failing in education, we have a theory which fails to meet any of the observations and fails to predict what we will find.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. On Jupiter's moon, Io. Since the late 1970s, scientists on Earth have studied the tremendous plumes of material ejected hundreds of kilometers from the moon's surface. The theory that these plumes are volcanic in nature and trace back to their discovery in 1979.
On March the 8th, 1979, 3 days after passing Jupiter, Voyager 1 took images of Jupiter's moons to help the mission controllers determine the spacecraft's exact location.
The tidal heating models. Lead author Christopher Hamilton says that the findings can't be reconciled with any existing solid body tidal heating models. But the mysteries surrounding Io's so-called volcanoes. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. A new scientific paper is challenging planetary scientists' ideas about the so-called volcano visions Jupiter's gravitational pull, creating tidal heating inside of Io. However, according to a recent geologic survey, the location of the so-called volcanic plumes is incompatible with the predictions of